大家好，我是中兴通讯的胡凯伟。
Hello everyone, I'm Kaiwei from ZTE Corporation. I would like to share with you some of our ideas and practices in mmWave. And 5G actually proceed to the second half. And the leaders of the three operators already mentioned this is a large project extend from urban area to rural areas. And during this process, there is a feature that is the sub-6. In the past, we had 3.5. 2.6, and now we have X700, 800, and 5G is going downward very quickly, and it actually swept the whole industry. Now there is an issue. We talk about 5.5G, 6G. When we face the 5.5G or 6G, the applications, for example, the 3D memo, as well as AI, VR technology, or the device inspection, vision inspection in the workshop, or the road vehicle connection. I believe that in the future, millimeter wave will play a really important role in this aspect, and this is also a complement to the band frequency. And actually started from 2018. When we started with the construction of 5G. Actually, China started with sub-6, and in US, millimeter wave is dominant. And actually, this can be divided into three stages: microwave, mmWave 1.0. In the beginning, we had FWA, home wireless broadband scenario, or second one, some 2B or some 2C hotspots. We use millimeter wave. For example, if we want to build a experience park, we can use it. And thirdly, we found out actually in terms of the penetration coverage, millimeter wave have some disadvantage, but it has high perception. So in the third stage, it's have new service like low altitude perception. And this part, millimeter wave play really important role. So in terms of applications, there are three stages. In the first stage, it's about FWA, home wireless broadband. The second one is the enhanced EMBB 10G experience. The third one is new services like low altitude perception. In terms of the technology, in the beginning, it's like 100 MHz, 2 channels, and some are only about 512 antenna arrays with the radiation of 62 dBm only. But now, in the whole world, you can see mainly it's about 400, 800 M above, and sometimes in narrow band, it's already reached 200 M. And with 4 to 8 channels and over 1,000 antenna arrays. So it's more diversified. Besides the AU, we also have some decentralized devices. To this stage, millimeter wave already upgrade from 1.0 to 2.0 and 3.0 in terms of not only application, but the deployment will also change. In 1.0, it's about the home wireless broadband. So in second stage, it's about integration with the ARC. And in third stage, we will have the LC networking. So this is about the development situation for ZTE. In the third stage, millimeter wave 3.0, we are the first one to make it to 1.6 GHz frequency and have 1024 antenna array, and we're the first one to do the diversified equipment and decentralized base station, and TRU and BBU was separated, and for the separated part in the middle part, we had radio frequency, and then this way we can largely reduce the amount of the bandwidth. It's really easy to deploy. And the second, for the traditional sub-6, and there is a hub in the middle, so it's a 3-layer, but now we turn it to 2-layer. So in this way, in terms of the diversified device, in terms of the deployment, sometimes it's more feasible. And in the intermediate independent network, NRDC, SAO, these have been well developed and improved. And the third part, in terms of the application, actually for ZTE, we work with China Telecom, and we had this large bandwidth backhaul helps vehicle ground system. In the past, we use the cord to do the coverage, and it's very hard for it to penetrate underground. But now in the channels of the metro, we deploy the mmWave device, and for sub 6G base station, we actually put it in the metro system directly. After we use this system, there are two features showed up. The first one is the application in the sea end have been largely improved because for the mmWave, because when you get into the metro, it actually largely improves the capacity as well as user experience. And also we pay attention to the 2B side computing power base station. And for the transportation, it's also largely improved and well used applied in transportation scenario. And when we do the internal system, its construction cost also largely dropped. So in these kind of special scenarios, there is a really good use case for the millimeter wave. And also for the backhaul system, and also we do the integrated perception and computing. And we have two research institutes in Shenzhen, and in Tech Park, we had actually a platform, and with the mmWave technology for 1 km single RU, we can detect the overall trajectory and as well as distance. And so this can reach a micro level. And in the future, we will actually also work on the deployment in the 6 km line with operator in order to build the system in Shenzhen. And for some drone companies in the past, actually we discussed with them a lot recently, and I believe there are demand like this. A lot of food delivery, they try to use drones, and also the as a receiving platform, they have actually left some space for the landing of the drones. And also for the drones logistic, for the millimeter wave, actually it has a very accurate detection of these devices, so it's really helpful. The next one is about the connection of the vehicle and road. And in the past, when we work on it, the vehicle road integration, we talk about we need to build a specialized network. Now, no matter for the low air economy or the connection of the road and vehicle, we actually use the network of the operator. And when we use it for communication, we also use it as a radar to perceive. And for the vehicle side, we can also achieve it. For example, if you drive the car, for the car nowadays, they are actually single car intelligence, and they can actually detect the potential obstacles within 100 meters. And also for the micrometer wave base station, we do the radar and perception. You can actually perceive the potential obstacles within 1 km and send the information to the driver. So this will largely improve the traffic safety and also many other aspects. Besides the millimeter wave base station, we also add some algorithm computing power panel and introduce computing power to the base station. So it will not only play the role of the bandwidth, it also plays the role of intelligence. So in this way, internally, it will largely help with the improvement. So for millimeter wave in ZTE, just like I just mentioned, we divide its development into three stages. The first one is about backhaul application. The second one is about a 10G experience, hotspot. The third one is about perception. And for the current technology, we've already approaching to the third stage. So during this process, started from 2018, we've already started to do the backhaul as well as working with domestic and broad operators to cooperate with them. And we also done a lot of tests and validation with the Unicom during the Winter Olympic. And we also partner with Qualcomm to done a lot of research. And for the three stages I just mentioned, the devices actually have been improved from 2 channels to 8 channels, and also the coverage have been largely improved. So to conclude, when we look at the development of mobile communication in the future, if terahertz is the direction of 6G, the millimeter wave will be the first step, because now we deploy the sub 6G, and for the China Mobile it's 2.6G by 10. If for the terahertz, it will be another 10 times. So for millimeter wave, it's the first step for us to approach to 6G era. That's all. Thank you.